Hi, this is Jamie Shudo and Colin Dake, and for MEGN 200 final project presentation, we present to you Plantelligence. Why is our product needed in society? Well, Plantelligence is a smart, sustainable solution for the modern plant owner. The problem we're solving is simple, but quite widespread. People love plants, but most don't actually know how to properly take care of them. They either overwater, underwater, or place their plants in poor conditions, which lead to frustration, wasted money, and dead plants. Our customers range from busy college students or working professionals and even older adults who want the benefits of indoor greenery without the guesswork. With Plantelligence, we've created an intelligent, user-friendly device that monitors your plant's environment, like soil moisture and light, and gives you real-time updates and care tips so that way your plant not only survives but thrives. In a world where mental wellness, sustainability, and smart living are more important than ever, Plantelligence helps people reconnect with nature confidently and effortlessly. It's not just a product, it's your plant's voice and your new green thumb.
So here is our plant taken care of robot. We have the plant here. We have the moisture sensor hooked up. We have our little light bar right here. And we have the pump right here connected up to this water bottle. And it will go into the plant. And then we have the user interface OLED right here. So you can select, you can use the potentiometer to, actually no, it's not in the right mode. So you can select the mode right here. You can kind of change the potentiometer and change the value and scroll down with this button. So that's like water, how many times a day you're gonna water the plant. And we have the how much light you want the plant to get. It's just an analog value basically. And then we have the upper moisture threshold, which we changed here. And then the lower moisture threshold, which yet again can be changed. And then we actually have the real-time moisture value shown on the screen as well, just to help you know what's going on.
And the plant is already watered, so that's why it's green.
Yep.
And the moisture is above the set threshold that we want it to be.
Mm-hmm.
So the pump is not running currently.
Yeah, and then we can turn on care mode, which, since it's seeing not enough light, it's going to activate these LEDs and also move the plant around to get a better angle on the sunlight. And then you can see no water is being pumped right now. It's not moving at all, but if we take out that,
It starts to pump
yeah,
water.
it starts to pump water, and then we put the moisture sensor back so it senses moist. This has already been watered and taken care of pretty well, but you get the idea of how this would work. And yeah, that's everything. It's packaged beautifully. It's amazing. Yeah.
Alright, here's the code for our final project. We include our libraries and pen definitions here. And then we have our OLED setup, which initializes the OLED. If it fails, the system will just halt. Then we have our variables here for the system control sensor values, timers, stepper motor, the light thresholds, and the fault detection. And the setup function right here, we initialize the OLED, pins, stepper speed, and the serial monitor. The pump is just then briefly turned on for 500 milliseconds as a test. And then in our void loop function, it reads the inputs, analog read sensors, digital read buttons, writes the current LED signal to the LED pin via analog write. And then if toggle UX mode activates, this is using the potentiometer and button 2 to adjust the settings. We have row 1, 2, 3, 4, 5, 6 on, nope, just 5 rows, my bad, on the OLED display. Button 2 cycles through the rows, and the user can adjust values for the active rows. We have pump on time, water timer, light goal, upper threshold, and lower threshold. If toggle, let's see, down here, The light management, if the light is too low, if shade isn't fully open it via the stepper. If still too dark, the shade is maxed out, increase the LED brightness. If maxed out and still too dark, it raises a fault. If the light is too high, it closes the shade, lowers the LED brightness, and raises a fault if unable to lower light level enough. We then have our status LEDs. Status 1 is if on, that means that it's working normally, so that's going to be the green LED, and then status 2, if that one's on, that's going to be the fault LED, so that one's going to be our red LED. Down here, we have our soil moisture watering logic. If the moisture reading is greater than the upper set threshold that we have, that means that the soil is fine, then the pump is going to turn off and the green LED is turning on to let the user know that the plant is fully watered and taken care of. If that moisture reading of the soil is less than that set threshold value, that means that the soil is then too dry, the pump is going to turn on, and the red LED is going to turn on until that moisture reading does meet that threshold. We then have our OLED display outputs. Every loop iteration, the OLED will just show pump on time, watering frequency, light goal, upper lower moisture thresholds, current moisture readings. We only have 6 rows shown because the OLED is small. But overall, the system's functionality, the code just enables the plant growing station to automatically maintain target light conditions using a window shade and LED, keeps that soil moisture within desired thresholds by watering it at a set intervals and based on real-time moisture readings, and lets a user tweak system settings via the potentiometer and the buttons, and displays all of this info clearly on the OSplay user interface display.